Hello, hello. Hello, everyone. Thanks for sticking with us for the end of the day here. Like they mentioned, we are a sponsor here at ConVerge, and I am, an actual tester. I'm not really like a marketing person. So if you want to come up to me and talk tech, talk what's going on with your shop, talk testing applications or penetration testing, please do that. Today's talk is going to be a little bit higher level. We're talking strategy and how we conduct product security tests, and generally how that fits into the larger security strategy within an organization. And as a little bit of a preview, here's kind of a diagram that we're going to come back to a little bit later in the talk that shows a little bit of the cycle that we're going through. I want to fill in a little bit of background before we get to that stage, though. One thing that's always important for us to discuss when we are starting a test with any client is that we're here to help. And generally, we run into these problems with engineers or with developers that feel like we're really there as an adversary, and they're really afraid, like, what if we have findings in our report? That's going to look bad for me. That's going to look bad for us as an organization. And that's really not the case. We're here to help you become better. And we really try to bend over backwards to do everything we can to make that happen for your organization. And another thing to keep in mind, too, is that having findings in your report might help you point out issues to stakeholders that you already suspect are there, but you need proof that it's there. And you need to show them why you need some additional attention or resources or whatever that is to make sure that those issues are fixed. So it's really not about blame or shame. It's about how we can help you become better from a security perspective. So a little bit about me. I'm a senior information security consultant with VDA Labs. We are a sponsor. VDA Labs is a boutique penetration testing and application assessment firm based out of Grand Rapids. And we'd love to talk to you if you want to come and visit us out in the hall. My background has been in development. I also used to own a small business and got started in security defending WordPress websites from all the bad stuff that we all know can happen to those, right? I am really interested personally in the intersection of business and security and how we can make security work better within organizations, not just find a technical solution and call that a done day there. And another thing that we're all passionate about at VDA Labs is training. So our trainings are going to be offered later this year at both Black Hat and DerbyCon, and specifically we've got hacking for developers is one of the courses that we're putting on, and also a malware reverse engineering type course, I believe, also. So let's start out with why this talk is necessary. Over the past 10 years, as you all have probably seen, products have changed a lot. There's more complexity, more different components involved, from hardware to industrial controls, building controllers, software, including microservices, APIs, and mix and match programming languages. Software has also shifted more from we're going to custom code something together to we're custom code something up to we're going to glue it together kind of mentality. And that basically means that products are way more complex than they used to be. And as a case in point, I recently stumbled across this example. So this is my cat playing with some fidget spinners that I actually brought back from Black Hat last year. And I was recently looking for an updated new litter box for him. And I came across this thing. So this is called the Litter Robot 3, and it's actually manufactured just out in Bloomfield here in Detroit area. So it's actually a really cool product. We have an older version of that at my house, but my version doesn't have the fancy phone connection and all of that. So let's talk a little bit about what this product actually is. This is a cat litter box that talks to the internet and to your phone to let you keep stats on how your cat is going to the bathroom and what the status is of that litter box. And that's crazy, right? But let's talk about that at a more technical level, because there's a whole bunch of different technologies involved making this actually possible. So that litter box is going to have microcontrollers running probably C or C++, at a very low level to monitor the actual physical properties of that device. Then it's going to connect to the network out to probably a cloud service that's going to collect the data about the usage of that litter box. And then it also has another relay where that's going to talk down to a mobile application running on your phone. So this one product has all of these different crazy components that are interacting in a bunch of different ways on the back end. So products have become way more complex, and that's something that we see every day, and why we kind of have to think through the approach to doing product security tests. So starting back at a little bit higher level, when you're going to go and perform a product security test, don't skip strategy. You have to accurately gauge what the high-level goals are from a security perspective within the organization, and also the security appetite within the organization, right? So someone who's producing a connected cat litter box isn't probably going to have as many security concerns as someone who's producing a medical device. Not that having a cat litter box hacked won't necessarily be a bad thing, right? That could cause reputational damage for the company. Those people are probably concerned about that, but it's not something that's going to end the world. So there's going to be different levels of security appetite. The other thing that's important to consider is the leadership within the organization. How much are they aware of security and what the impacts could be for them? And budget also always comes into these discussions as well. So when you're talking to somebody like a chief security officer, they have all these different things on their plate. GRC, regulations, business need versus budget, balancing those kind of high-level concerns with strategic goals around automation, metrics, building a qualified team, all of these different things. Oh yeah, and testing. Testing is a thing that's a part of their concern, but not the main thing. So it's important to be able to kind of bridge that gap and help them understand how testing then speaks into those other areas that are of concern. So another thing that we believe at VDA is that testing for products specifically is best done by a team. And the reason for that is when you're talking about a really complex application or product, there's so many different attack surface areas that you're going to be looking at, from APIs to low-level, hardware. Even when you're talking about an embedded device, there's different types of expertise that are needed for those different types of testing, and that's why we really are fond of a team approach, and we like to bring in different people with different perspectives to look at those different areas. So as another kind of background piece of knowledge, many people are familiar with the corporate penetration test process. So a corporate penetration test would generally include things like external, where you're attacking from the internet, applications, where you might be looking at websites that are publicly facing, internal, where you're testing internally to the corporate network to see what vulnerabilities are there, wireless, social engineering, physical, where you might be trying to break into a building, and then reporting. So that's kind of the standard penetration test model that a lot of people are familiar with. But what does a code or device or product penetration test look like by comparison? Well, reporting is definitely still a part of it, so that's for sure. But we kind of like to take it from this level where we're looking at first doing some kind of SDL assessment and understanding where the developers are at with their security understanding, and have they been factoring in security from an architecture and design perspective. We also do make sure we take time to ramp up our domain knowledge when it comes to working in a specific area, because every different type of group we're working with has different security concerns. And then we get into actually doing code testing, whether that's component, static, dynamic, manual. That's kind of the steps we're going to talk about later. And then triage, remediation, and re-engineering. But before we get into that, a little bit more background knowledge. So for the developer team, what kind of security concerns are important? At VDA, we like to talk about pushing security to the left. And what that means to us is pushing security concerns earlier in the process when it comes to a product. The idea behind that is if you're thinking about security from the inception of a product as opposed to just reactionarily looking at it at the end, you're going to have a much more secure product. You're going to have a much more secure process and all of that at the end. Not just a plate full of findings that nobody has really thought about until you get to that stage. We also like to discuss these different continuous improvement models with our clients. So Microsoft's SDL, Synopsys BSIM, OWASP SAM. We don't really have a lot of time to dive into those, but I do want to point out some kind of interesting things about them. These are basically ways that you can assess where your organization is at when it comes to the security of your development processes, and then kind of build some goals to where you want to be. So within the Microsoft SDL, you're kind of tracking from requirements all the way up through implementation, verification, and release. And as you can see in this diagram, fuzz testing, for example, dynamic analysis and static analysis are components of that life cycle. And not every organization is going to be able to implement this at the kind of level we would like to see. And in some cases, that's why they're supplementing what they're doing with a team like ours. So this is Synopsys BSIM. For comparison, Synopsys BSIM is basically a study of what a group of well-recognized leaders are doing in their security practices. And as you can see, again, security testing is a small portion of this, but the more different areas of this that you can take into account with your development process, the better you're going to be off security-wise. And lastly, OWASP SAM. I really do like this model because it is very simple when it comes to the 4 different buckets that they put their activities under: governance, construction, verification, and operations. Testing, security testing is part of the verification process here. And the other cool thing about SAM is it makes it very easy for you to take a quick assessment, understand where you are at, and then build a roadmap based on what's a reasonable expectation for where we want to be in 6 months from now, 12 months from now, 18 months from now. And the other thing that they make sure to consider in their model is that their grades go from a 1 to 3 scale, and they're very conscious about pointing out that not everybody needs to be at a 3, right? Everybody has a different security appetite and need for security within their organization or product. So why do coding mistakes happen, and what can we do about it? One of the big issues is failure to train coders on security issues, and just wanted to point out that our founder, Jared DeMott at VDA Labs, has a training course up on Pluralsight where you can learn more about that. And I have coupon codes at our booth out in the hall for a free month of Pluralsight training. And so you can get those from me tomorrow. And there's plenty of other courses besides Jared's as well. So come and talk to me. Another thing is tight deadlines. That's always going to be a problem, right? Everybody wants to turn around software faster and faster, and that's why we're adopting these things like DevOps so that we can be deploying multiple times a day, but that might not be the best thing from a security perspective. And lack of proper testing budget. Again, this is where a technical debt can stack up and come back to bite you. Other things that might cause security issues is things like not using proper new technologies to protect against exploits. So DEP and ASLR are examples of that. Great things that are built into, for example, Microsoft Windows 10 that weren't necessarily there in older versions of the operating system. A really great example of this just came out over the past week, where a vulnerability was discovered in 7-Zip, which is probably a program that many of us use. And that was found to be possible because that author of that software was not compiling it with ASLR enabled. ASLR is address-space layout randomization, and it's been around for quite a long time, and he just wasn't doing it for some reason, which made this exploit potentially very bad. Another very common source of bugs are bringing them in from the outside or importing bugs from third-party libraries. This is the classic thing that happened with Equifax and Apache struts, right? Using a third-party library, this is very handy. We're going to accelerate our development by using something that's pre-built, but then we're not going to pay the attention needed to keep it up to date, and we've got owned and caused a huge data breach. Plenty of problems like that happening all the time. And another area where bugs potentially happen is where there's lack of clarity or confusing API calls, and we really like to find the parts of software where two different systems are communicating to each other, especially two different systems that might be developed by two different teams within the same company, because that often leaves the potential for gaps in places that they don't necessarily match up quite right, and we can find holes in that. But it's really important just to get the basics right. Things like secure passwords, storing data correctly, and really just secure design. Considering how your product is going to be built from a security perspective from the very start, and even potentially not incorporating a certain feature into your product because it might open up too many doors to potential issues, right? We've seen that before where there's, for example, a SQL query builder in this web application. Well, what might that allow you to do if you were trying to do something nefarious? Could you maybe query the database and get some other user's data out of it? That could be very possible, right? So thinking through the potential complications that you're introducing with a new feature is always important. And lastly, another thing that we always like to say is that not every device is built with the type of security that's necessary to put it straight on the internet. A great example of that was discovered recently when Memcached instances were exploited around the world to cause, I think, the largest DDoS attack that ever happened, basically because these instances of Memcached were exposing a port to the internet that was never supposed to be exposed to the internet. It was supposed to be a local interface that was talked to by the system, but it instead allowed attacks to be relayed through these open instances without any authentication. And next, making sure you're using strong passwords, and even better, using VPNs and 2FA to get access to systems. That's always something we want to recommend. No matter what the system is, if there's any sort of sensitive information, you should be using a 2FA to get into it. And another thing that's easily forgotten in the age of complex products is software updates. And this was touched on in one of the earlier talks here. When you're deploying a product, you need to consider the life cycle of the both hardware and software that's being sent out into the world. Because if you're going to develop something now, it may need to be supported for how many years? Your company really should know that before you put it out there, and make sure that it's known to the customers as well. And it's very common to deploy something and have consumers especially not think about it again, but IT people do that too. So you can't assume that it's going to be updated. And so you have to do everything you can to make that, enable that process. Lastly, we do We do also like to talk about protecting intellectual property through doing things like obfuscating code and hiding software and firmware updates. The reality is that if your attackers are really persistent, they will be able to get around those types of attempts, but it can potentially slow them down. And also, putting things into your code such as canaries can help you determine if someone is really looking at it at that level. So for example, some type of canary token in the actual binary that isn't used for anything except when somebody finds it after decompiling your code could give you a hint that someone is really digging at your stuff. And another point is always make sure that you've got a channel for researchers or security professionals to reach out to you about your product. Having a simple secure@companyname.com email address is definitely a good step. And then having the accountability to follow up with those types of information that come in. You don't want to be like the oracle that's going to hire lawyers when they see some kind of issue come up. You want to be someone who's friendly to that and know that if a security researcher is bringing you something, they're not necessarily out for blood. So that's the background that I wanted to go over. Now we're actually going to dig into the meat a little bit of how we conduct product security reviews. And that really starts out with scoping. And that's kind of an area that is a little bit tricky when you're talking about a complex product. Whether you're talking about a car, building controller, IoT device, these are the steps that we kind of take from a consulting perspective. So when you're trying to scope out the process, you have to talk about what's in scope. Because when you're talking about testing a complex product, you have to understand where the edges of that product actually are. What's in scope? What do they have budget to test? And what are the technologies involved? What approach did they want you to take? It gets pretty complicated pretty fast. Oftentimes clients will come to us and say, we really just want to see what a hacker can do with this system. They're kind of taking the perspective of, okay, a hacker isn't going to have any background knowledge on what this system is like. And so they want to see what someone with zero knowledge can do to it. And that's fine. We perform black box tests all the time. But for us, the question really should be, how many bugs do you want to find in this system? Because if you want to enable us to find more bugs at a deeper level, that sometimes requires getting a lot more access than just a URL with a login or something like that. Oftentimes, we'll request different levels of access to an application through credentials at like a normal user, a super user, and like an admin. We may go as far as getting shells on the actual server that's hosting the product or whatever that is, so that we can really dig into the deep logic level and see how our attacks are affecting that service behind the scenes. And in a lot of cases, we will actually request and review source code for a product. Some customers think that might be cheating. We really don't think that at all. We think that that is what enables us to do our job better, do our job faster, and find more bugs for you. Sometimes customers have a different thing in mind and they don't want to find as many bugs, and that's fine too. We are happy to do black box tests, and we do all the time, but we always like to steer people, if we can, towards doing a more white box test where we have access to those additional things, because ultimately our goal is to make you and your product more secure rather than just poking at it from a very perimeter perspective and something that's opaque. And the cool thing is that the BSIM model actually reinforces that thought. If you can see here, BSIM ranks these different activities in level 1, 2, and 3, and the idea is the levels are increased levels of maturity within an organization. So under level 2 here, providing a penetration tester with all available information is a sign that your organization is more mature than somebody who's just going to ask for a black box test. So, digging further into the actual start of the process, since we've done scoping at this point, the first thing we really have to do when we're beginning an assessment of a product is the initial system investigation. And this is a really cool part of a process or of a product assessment for us, because generally we're looking at a type of thing that we've never seen before. And that means that we've got to figure out how to get it set up and working, and then understand how it's supposed to do what it does, so that we can then figure out how to make it do things that it's not supposed to do. It's a very, very exciting part of the job, definitely, because it's always something new here. We've done all kinds of crazy different tests, from automotive to IoT, web applications to all sorts of interesting things, and this is definitely some of the funner parts of the project here. This is also where we begin to take a look at what the attack perimeter might be on the product as well. So we can see that this thing is talking to the Wi-Fi on your network and going up to the cloud. So there might be an API in there that we can look at, all sorts of things like that. But the important thing to understand there too is not all of those things might be in scope, right? So a device could be talking to a service, but that service might be a third party, and you're not allowed to touch that during the test. That's very common, in fact. Another thing that happens during this initial investigation is looking for the different tools that we're going to use during our test. So, really cool thing about our industry, many of you are probably aware of, is that it moves so fast. There's constantly new tools and techniques that are being, shared out on the web, whether that's through GitHub or talks at conferences like this. You have to stay on top of what the latest and greatest tools are for doing any particular type of analysis. And this is especially true when it comes to product security, because we're often seeing products that are developed with a big mix of different technologies, and there might be a new tool for testing one of those specific programming languages, for example, and we're going to talk a little bit about that later. The other thing to point out here is that sometimes hardware tools can matter for doing product assessments, because if you don't have the right hardware device to test against or dump the firmware out of whatever you're testing, that could potentially be an issue as well. Next, we also incorporate an element of kind of OSINT into this part of the process as well. Generally, even if it's a proprietary product developed by a business, you can dig on the internet to find interesting tidbits that might help you during the assessment. So that could be things like technician data, default passwords, engineering information. So like if there's a microcontroller baked into that device, what details can you find out about it by pulling up the spec sheets? CVEs are another thing. So just because your product is something new, that doesn't mean there isn't some component of it that has a known vulnerability. All sorts of interesting things like that. It also is necessary at this stage to learn some additional domain knowledge in some cases. So certain types of organizations have different areas that are of concern to them. And again, this is where you have to potentially understand that at a deeper level. A good example of that is if you're dealing with something like a medical device or a car, safety might be one of the highest level concerns. Whereas if you're dealing with, money or finance, it could be stealing money or availability. And defense, for example, would be concerned with secrecy or weaponization of potential issues that are found in the product. So coming back to the diagram, at this point we've kind of completed the initial investigation. So now we're really going to dig into the analysis of the product. Because most systems aren't that easy to hack, where you're just going to Google it and find a way to suddenly crack it open. It usually takes some more steps than that. So from this point, we like to take what I like to call a kind of kitchen sink approach to testing. And that means basically we're going to find everything we can to throw at this product and shake out as many bugs as possible. And so if we've actually got source code and or binaries for the product that we're dealing with, the next stage is going to be doing this automated analysis on the code or binary. This is also called static analysis, and industry vendors will call this like SAST, static application security testing. And then from there we'll move on to automated analysis of the attack surface. That would be what's called dynamic analysis, where you're actually testing against the application at runtime. And then we move on to manual hacking. And we like to think of manual hacking as kind of pulling together everything else that was discovered through automated means, and then also looking for things that really it takes a human to find versus just a system that's going to automatically go through and try to find output. And we also feel strongly in showing impact through our testing, not just finding the technical flaw, but showing why it's important. And we'll get into why we think that as well. So when we're doing these types of tests, what types of bugs we're looking for kind of depends on the type of language or product that we're looking at. So for example, if you're dealing with C or C++, say an IoT device that's got an embedded system, you could be looking for buffer overflows and heap issues, things like that. Whereas if you get into more like scripting languages or .NET, it could be more things like authentication bypass, command injection, cryptography issues, and so on. And then if you're dealing with web applications, the flaws would be kind of more generally in the OWASP top 10 kind of area. So basically different types of products will have different types of bugs, and we're looking for those in a little bit different ways. If you're not familiar with the OWASP top 10, here's kind of the overview. Not going to dig into this, but these are very common issues that are found across web applications, and that's why they compile it into this list. Things like injection, that would include SQL or command injection, broken authentication, where you can get to something that you aren't necessarily supposed to get into, sensitive data exposure. A good example of that would be being able to download a file that shouldn't be publicly accessible or whatever that is. The point is, these are the general buckets that we're looking for on a web application. And to kind of get started into the testing phase here, we're going to show you some different screenshots of the tools that we're using, kind of talk through what they are and why we're using them. So this is the .peek tool, which is created by JetBrains, and this will decompile .NET code from its compiled form back into readable code. So why do we want to do that? Readable code is a lot easier to understand than bytecode or whatever you'd be looking at otherwise. So if we have access to those binaries, decompiling them is very helpful. It also allows us to check for things like hard-coded credentials, weak cryptography, and things like that. And so that would be a case where like a binary was provided, but the source code wasn't provided. You'd have to do that kind of tool. On the furthest end of the spectrum, if you've got like a C, say you've dumped the firmware off of an embedded device, you might just have a blob that you have to decompile using something like Binary Ninja or IDA Pro. At this level, you'd be looking at bytecode to try to understand what's going on with that application and to try to find out, where might a logic flaw be that we can poke a hole in. So digging into static analysis. Static analysis is really cool. It's a broad technique because it allows you to potentially take a whole bunch of source code, right? All of the source code for the product and dump it into a tool that's going to analyze it and find potential issues in the code. So it's really great because it works on all of the code. and it can scale well because you can, like, it doesn't matter if there's 1 million lines of code, 50 lines of code, you can put it in there and it'll be able to get a report to you. The con of static analysis techniques is there tends to be a lot of false positives. And that's for many reasons, but generally one of them that's pretty common is that whatever flaw was discovered isn't in any attack surface area that can actually be exploited as the thing is deployed in reality. And you'll see kind of an example of this coming up. So what you want to avoid doing is running static analysis against your code and then finding 1,000 different errors, bringing them to your developer and saying, hey, Mr. Developer, look at all these problems in your code. Because your developer might then take that report, spend 8 hours looking through it, come back to you and say, none of these are actually real flaws. Go away, I don't want to talk to you anymore. And that kind of problem, or that kind of situation can really cause a problem within your organization because it's going to turn that person off to security overall, and your efforts are just going to end up hitting a brick wall. So if you're going to roll out any type of static analysis within your organization, it's important to really have a plan in mind for how you're going to triage those flaws from the beginning so that you're not just taking a raw fire hose worth of output and dumping it on some poor developer. You have to really plan to focus in on what are the really critical things, how do we identify those in a targeted way, and prove out whether or not they're legitimate or not. So when we're talking about static analysis tools, there's both commercial and open source options for that. We like to use both Veracode and Synopsys tools in the work that we do, which are really nice, but they do cost money. So that's something to keep in mind. But there are open source options, and I think I mentioned this before, but in some cases those open source options are very specific to a certain type of code or certain type of platform. So for example, we do know that there's a very good Ruby static analysis tool, but there might not be such a good one for Golang or something like that. And this is an example of the Gartner Magic Quadrant. Do you feel the magic? This kind of ranks the different application security tooling into different types of, categories, but Veracode and Synopsys are up here in the kind of winning quadrant, and again, we like them quite a bit from our experience. It's also worth mentioning here, this quadrant, or this diagram does include static analysis, dynamic analysis, but also interactive analysis, which is a kind of newer technique that's kind of interesting, but we're kind of in a wait and see approach with that one. The idea behind interactive analysis is that it will run an agent server side that will be able to communicate with the testing mechanism to have better fidelity in the detection of issues. But we're not sure yet that that value is actually there, so we're waiting to see that. Another technique that's that's used by us way early on in the process is software composition analysis. And this is where we're talking about trying to identify those imported bugs and issues. The idea is you take the binaries or whatever it is that the client has given you, drop them into this tool, and it's going to parse through that and identify, okay, this software is made up of this and this and this and this, and here's all of the CVEs or vulnerabilities that apply to that software. And this can be very helpful. For example, if you saw something, oh, sorry, I'm not, I didn't jump ahead yet. You get out a chart, something like this, and you can see, oh man, we've got a lot of vulnerabilities. And if you saw something like Apache struts on this list, you would definitely have cause to be concerned. In this case, this is an example from Wi-Fi router firmware, and it's identified, you can't see it very well, but 360 vulnerabilities in the outdated Linux kernel that's deployed on this system. Well, chances are there's not going to be anywhere near 360 different ways that you can exploit that device in the wild. It's definitely a cause for concern, though. So you have to take these results with a grain of salt. We do like this as a kind of usable metric, though, because over time, if you're able to perform this type of analysis as you're releasing new iterations of a product, you definitely would want to see those numbers trending down as opposed to up. So it's a usable metric that way. This is an example of Vericode's software composition analysis output. Again, same thing, it's identified one critical level flaw in, I think that's Apache Spring, but same type of output, different type of format. So then getting into the actual static analysis tooling, Vericode and Synopsys, again, are the commercial providers that we use. They're kind of cool because they're different in a way. Vericode, for example, runs a cloud-based service where you upload your items to the cloud and it does analysis for you out there. Synopsys Coverity, on the other hand, is more developer-focused and will actually compile the code and build it and identify vulnerabilities that way. Open source options, Brakeman for Ruby is one that we found and really like. There's also Visual Studio plugins for .NET, PumaScan and Security Code Scan are two options for that. So I've just got a couple of quick output examples. So this is what you might see out of Vericode's Cloud Scanner. SAST product, so we found OS command injection. Again, like, just because it's found the potential for this in the code doesn't mean that it's actually exploitable. So that's why we actually have to follow up and continue through the cycle. And this is Coverity, for example. And again, this is where it shows it kind of in an inline with the code type of view, which is really neat because you can see exactly where that injection point might be in the software right away. And here's the example from a Visual Studio plugin. As you can see, when a coder is it's a little fuzzy, but when a coder is developing, they'll be able to see, okay, this line right here might have this potential cryptography issue. And then Brakeman, again, is the Ruby tool that we really like to use. So moving on to the dynamic analysis. Dynamic analysis is really cool because you're actually investigating the runtime attack surface area as opposed to like the theoretical attack surface area of SAST. And so the idea is that you'll have less false positives here because if you can actually tweak something and exploit something in this setup, you know, you're actually doing it against a live product, so it's a real thing. But the con is that if this is the only attack surface area that you're looking at, you'd be less likely to find deeper bugs. So when you're doing dynamic analysis, sometimes you can only do dynamic analysis, like in the case where a client is not willing to provide you with source code or binaries or anything like that. They just want to see what a hacker can do. You're only doing dynamic analysis potentially. So you might not be able to see under the scenes or under the hood, behind the scenes or under the hood to get those deeper flaws. From a dynamic analysis perspective, we really like an open source tool called Arachne. It's freely available to download, and we've used this very successfully on a number of jobs. And we use this actually in complement to commercial tools like Vericode, again, does both static and dynamic analysis. And we find that using both is really what gets us the best results, because not every security tool is going to measure or seek out the same types of vulnerabilities. So, great example of this, recently had a job where ran Vericode, didn't find any critical findings, ran Arachne, and it discovered output, debug output from a certain parameter that included full API keys for all the cloud services that this site was connected to. And that's just one example of how one tool might not find everything. And that's because, testing is an NP-hard problem where you can never really prove something is completely secure. Each tool or each approach might be a little bit different, but combining them together, we really find we get the best results. So Arachne also has a web interface, which can be pretty handy. I think that allows you to track things over time as well. And then I'm not going to talk much about fuzz testing, but that's another area that can be necessary depending on what the application is. So you can fuzz test against the Ethernet interface of a particular product and find a vulnerability that way. We've actually discovered that through crashing a certain device, we were able to bypass it, for example. American Fuzzy Lop is kind of the main fuzzer that's really well known right now, and basically what that'll do is mutate input to a specific program until it causes a crash. Kind of running short on time, so I'm going to speed up just a little bit here. So manual hacking. Basically, we see manual hacking as the place where the results from static analysis and dynamic analysis come together, and then where we do deeper investigations into areas where only a trained professional is going to find issues. So manual hacking could include things like code review if code is provided, reverse engineering, or just pulling together things that are found so far during the testing. One of the main tools we like to use for manual hacking is Burp Suite. If you're not familiar with it, Burp Suite is a man-in-the-middle proxy that'll allow you to send and capture communications between two systems. So the idea is you're going to capture the communications between a server and a client, fiddle something in there and see what happens. Burp Suite also does include some dynamic analysis tools as well, automatic dynamic analysis tools, and you can get both a free version of Burp as well as a commercial version for a really reasonable price. So if you're doing any type of work like this, Burp Suite is well worth it. Doing code review, you might be looking for certain specific things in the code. If you've got a huge code-based audit, you're not necessarily going to be able to read through it line by line, but what you can do is see if, for example, OWASP has resources dedicated to .NET code and Java code and PHP code to help you identify where issues typically come up. And so if you're looking at that specifically, you might want to dig into those areas. Lastly, proof of concept, your chance to show impact. So why do we want to show impact? Don't we have bigger fish to fry and want to spend our time actually looking for vulnerabilities? Sure, but we really feel at VDA Labs that if we don't show the impact of a vulnerability through something like a video or a script that's a POC, or dumping access to private information or whatever that might be in the system, it doesn't help stakeholders understand why what we're doing is important. And so if at all possible, we really want to go through and show what our attack enables us to do. So that could be actually doing command injection or using something like default credentials to discover, we can see this camera system that's not supposed to be accessible publicly, or, actually pulling out private information from a database. We really encourage everyone to keep it ethical, right? We have to do that in this security industry, but you also have to just push a little bit. You have to push people so that they understand the impact of what you're doing. And last step, reporting and communicating results. Reporting, very, very common practice, right? You got to make sure that all of your reports are well written. Executive summary, story of how you found the exploits that you did find, ordered findings, and remediations that make sense and are actually applicable to what you did find. Other things that are important when considering reporting is that it might make sense to meet with people in person, because oftentimes that's just a much better way to communicate information in addition to providing that written report. And also, your report might have to speak to both a product engineer on the one hand and someone like a CISO on the other hand. So it has to be something that's understandable at both of those levels. And lastly, something that we find very important is to communicate that no organization is a zero when it comes to security, and really none are tens either. Everybody mostly lies somewhere in the middle of that spectrum, and so we don't want people to feel bad that we found findings on a report. And we also like to say that, or we also like to include in our reports things that clients have done well. So if there's something that is especially well concerned or especially well secured, or designed in a way that's really good, or just implemented well, we like to point that out too. So that's kind of the end. The important thing to consider is that security is hard, and we don't want to beat people up with these reports and our findings. We want to enable people to become better. So that's really what we try to aim for in our security testing, and hope you found this informative. Thank you.